In this video, we're going to start a chapter on factoring and quadratic equations. All right, in this particular video, in this particular section, we're going to talk about an introduction to factoring, which includes the greatest common factor and one of the first methods that we always want to do when we factor, which is factoring by grouping. So this video has a lot of content in it. The first thing I want to do is talk about what we mean by factoring polynomials. All right, this is a procedure. It is a process of rewriting a polynomial as the product. Remember, product means multiplication, but as the product or multiplication of two or more polynomials. So I want to go from a polynomial that's written out just as we normally would write it out to be a multiplication of two or more polynomials. And the only purpose that this serves is it gives us a way to solve polynomials, and I'm going to abbreviate that with poly, of degree 2 or 3. And actually, we can actually factor polynomials of higher degrees, but for the purposes of what we're going to do in this course, we're going to mainly look at polynomials of degree 2 and 3. The first thing that we always want to look at when we're factoring is to be able to find what we call the greatest common factor. All right, the greatest common factor. And basically, the greatest common factor is the largest number or variable that is a factor of each term in an algebraic expression. And remember, what I mean by factors are things that multiply to give you something or divides evenly into something. For instance, if I look at 10, right, my factors of 10 are, let's say, 1, 2, 5, and 10. These are numbers that goes evenly into 10. Or these are the actual integers or the whole numbers that I actually can multiply by another whole number to get 10. For instance, 1 times 10 is 10, 2 times 5 is 10, right? And so when I want to come up with the greatest common factor of two or more numbers, I'm going to come up with the largest factor that's a factor of two numbers. Let's look at how we can find them when we're dealing with integers. The first thing we're going to do is we're going to find the prime factorization of each integer. Then we're going to write the prime factors that are common to each integer, and our GCF will be the product of these factors. Let's look at an example where we do this. In this first example, we have find the GCF of 36 and 45. All right, I'm going to use those steps once again. I'm going to first start by finding the prime factorization, right? Remember, we use our factor tree. So for 36, it goes on the top of our tree. 2 is the smallest prime number that goes evenly into 36, and it does so 18 times. Since 2 is a prime number, I'm going to continue my tree only under 18. 18 can be written as 2 times 9, and 9 can be written as 3 times 3. And so one way that we can write 36 is as 2 times 2 times 3 times 3, or we can say 2 squared times 3 squared. Now I'm going to go to 45. I'm going to do the prime factorization of 45. 2 doesn't go evenly into it, but 3 does 15 times. 3 is prime, 15 is not, so I'll continue under 15. And 15 can be written as 3 times 5. And so I can really rewrite 45, and I'm going to do it under here, as 3 times 3 times 5, which is the same thing as 3 squared times 5. And so since I have the prime factorization of each of these numbers, I'm ready to find the greatest common factor. And if I look, I got to look at what numbers they have in common. As we can see here, they have a 3 in common. And 3 is the only number that they have in common, right? This one has a 2, but this one doesn't have a 2, right? So 36 has a 2 as a factor, but 5 doesn't. And 45 has 5 as a factor, but 36 doesn't, right? So that means the 2 and the 5 are not common. We only have the 3's that are common. And so in my GCF, I know that it is going to have a 3 in it. And what I always remind myself is that I need to take all the 3's that I can take out of both of them. And one way to think about it is to look at the exponents here. In this case, it has 2 3's as factors, which is the same thing as 9. And so I need a 3 squared in my GCF. And 3 squared is 9. Therefore, my greatest common factor between 36 and 45 is 9. let's talk about finding the greatest common factor of variables. All right. What we want to do is we want to, we don't go through the whole prime factorization process because with variables, they are pretty much in their prime factorization. All right. And so what we do here is we get factors that are factors of each term, or common factors, right? And then we take the smallest power of the variable. And we'll talk about why we're going to do this. Let's look at this example here. I have x to the fifth and x cubed times y. All right. You don't have to necessarily go through this process, but I want you to know why we take the smallest power of the variable. X to the fifth is x times x times x times x times x. All right. X cubed times y is x times x times x times y. And so what we really do here is we see all of the factors that they have in common, or all of the factors of both of those polynomials, right? And so if I want to look at what they have in common, well, these three x's are what they have in common, right? And so when I look at writing my GCF, it's going to be those x's multiplied, which is x cubed. Notice this one has some extra x's, but this one does not have the extra x's. So I can't put those other x's in my GCF. And likewise, this one has a y in it, but this one right here doesn't have a y in it. And so my GCF has to be x cubed. All right. And so if you notice, when we look at these exponents here, of course, here you can see that x to the fifth, we have an x cubed here. This one doesn't have a y, but that one does. So x is the only variable that they have in common. And we always take the smallest power because the smallest power will always represent what they have in common. All right, so always remember, take the smallest power when you're dealing with stuff to exponents. Let's look at another example. In this example, we're going to find the GCF of 21x to the 8th and 45x squared. Now, what I want to happen is for you to get to the point where you don't have to go through doing a factor tree to find the prime factorization of a number, or looking at writing this out, these variables out in this form right here. I want you to be able to look at expressions like these and automatically know, okay, well, what number or what integers do 21 and 45, what factors do they have in common? What's the largest one? And then you have to remember that, hey, if you look at variables, you have to make sure that both of these expressions have the same variable. And also, you need to take the smallest exponent. And so if I look at this, I'm going to think about 21 and 45. Their greatest common factor, if I try to do it without writing so much, again, if you need to go through the prime factorization process, by all means do so. But if not, you look at your 21 and 45 and want to look at the largest number that they have in common. All right, that is a common factor, and that will be 3. And since both of these expressions have an x in them, remember we take the smallest power, and the smallest exponent or power is 2. So our greatest common factor will be 3x squared. All right, the next thing we want to talk about is actually factoring out the GCF of polynomials. All right. Not only should we want to be able to find the greatest common factor, but we want to factor it out. And this is going to be our first method of factoring. First method of factoring is to factor out the GCF. All right. And we'll be able to reveal what we mean by factoring with examples like this. All right. The steps that we're going to take here, we're going to find the GCF, right? And one thing that's going to be important with finding the GCF is that if the leading coefficient is negative, we're going to make the GCF negative. And this is more of a structural or a looking ahead type thing that makes things easier for us in the future. All right. So if our leading coefficient, remember that's the coefficient on the highest exponent on the variable, is negative, then we're going to factor out the negative, or we're going to make that GCF negative as well. All right. The part that gets to factoring is when we multiply and divide by the GCF, right? Now, if I multiply and divide by the same number, all right, I'm going to come off to the side here. For instance, if I take x and I multiply it by 2 and I divide it by 2, all right? What I'm really doing here is I'm multiplying by 1 because 2 divided by 2 cancels. And so we're going to go through the process of multiplying by 2 and dividing by 2, But we're not going to do this cancellation that you see right here. We're not going to go through the process of cancellation, all right? This multiplying and dividing is a clever way for us to actually rewrite that polynomial as the product of two other polynomials. And so we're not going to do the cancellations, even though it seems like that's going to be the natural thing to do. After we do this multiplication and division, we're going to simplify, and then we're going to check to make sure we factored correctly. Let's look at two examples. All right. This first example involves a polynomial. It's negative 8x cubed plus 12x squared minus 16x. And our instructions here are to factor out the GCF. All right, factor out the GCF. And so what I'm going to do now is I'm going to first start by looking at the values or the coefficients here. I have a negative 8, I have a 12, and I have a 16. Again, you can go through the prime factorization process to find your greatest common factor, or you can just look at 8, 12, and 16 and try to determine what number will be your greatest common factor. All right. If you think about the factors of 8, 4 is a factor of 8, 4 is also a factor of 12, and 4 is also a factor of 16. And so I'm going to make a 4 part of my GCF. Now I'm going to go to my variables. I got an x cubed, x to the second power, and x to the first power. Remember, when we're dealing with GCF, we take the smallest power of the variable, which is 1. So I'm going to have a 4x. And I also mentioned in the last slide that, hey, if our leading coefficient, which is negative 8, is negative, then we're going to make our GCF negative. And so this is going to be a negative 4x. So this is my GCF, all right? Now, I hadn't actually gotten to the part where we factor out. All I've done so far was I just found my GCF, which is negative 4x. What I'm going to do now is I'm going to do that second step, which told me to multiply and divide by the GCF, all right? And the way we do that is right, just like this. So this polynomial here is going to equal, I'm going to multiply by my GCF on the outside. And remember, I'm going to put a parentheses here. And remember, always, anytime you have an expression and then a parentheses, there's understood to be a multiplication. So this is my multiplication that I see right here. Inside the parentheses, I'm actually going to divide. I'm going to take that 8x cubed plus 12x squared minus 16x, and I'm going to divide it by my GCF. Okay, and now I see that multiplication and division. Now the rest of factoring this is to write this as a product of two polynomials. One of my polynomials is the GCF. The other polynomial is going to come from me simplifying whatever is in parentheses. And so in the last chapter, we looked at multiplying and dividing polynomials. And this is a monomial being divided into a polynomial. So I've got to take this negative 4x and divide it into this first term, this second term, and this third term, right? And so what we're going to get here is I'm going to still have my negative 4x on the outside. And when I divide the negative 8x cubed by the negative 4x, the negative divided by a negative is a positive, and 8 divided by 4 is 2. X cubed divided by x is x squared. So I'm going to get a 2x squared. Now I'm going to go to divide 12x squared by negative 4x. Positive divided by negative is a negative. 12 divided by 4 is 3. X squared divided by x is x. And then last but not least, I've got to divide this negative 16x by the negative 4x. Negative divided by negative is a positive. 16 divided by 4 is 4. X divided by x is 1. Of course, 4 times 1 is 4. All right. And so now I have this written out, and this is my final product. This is my solution here. All right. I factored out my greatest common factor, which is the negative 4x. And in parentheses, I divide it to get 2x squared minus 3x plus 4. All right. Now, we can always check ourselves to make sure that we did this correctly. All right. In order to check yourself, of course, this sets up a distributive property. So I'm going to distribute and see if I get the same thing that I started with, which is right here. All right. So negative 4x times a 2x squared is a negative 8x cubed. Negative 4x times a negative 3x is a positive 12x squared. And negative 4x times 4 is a negative 16x. And as you can see, this is the same thing as what we started with here. And so this is my true solution. All right. And we've gone through the process of factoring out the GCF. Let's look at one more example, because sometimes these get a little bit more complicated. In this example here, I have an 8x times the quantity 5x plus 4 minus 3 times the quantity 5x plus 4. Again, the first thing I've got to do is I got to figure out what my GCF is. All right, in figuring out my GCF, again, let's look at our values out front. I have an 8 and a 3. 8 and 3, they don't have a greatest common factor other than 1, and we normally don't write a 1 here. Notice I have an x on the outside of this parentheses, but on this one I don't have an x on the outside of the parentheses, so x is not going to be in my GCF. But look here, I have a 5x plus 4 that's multiplied by this 8x, so that means 5x plus 4 is a factor of this entire expression here, this entire term. And I have a 3 times a 5x plus 4. That means 5x plus 4 is a factor of this term right here. And so my greatest common factor is actually going to be a 5x plus 4. And so the thing that we're going to be multiplying and dividing by when we do our factoring by grouping here is that 5x plus 4. So I'm going to take my 5x plus 4, multiply it on the outside. And on the inside, I've got to divide it, right? That's our factoring step. All right, when I do this division, right, I'm going to take this entire 5x plus 4. Now, when we did it in the last chapter, we said that when we have a polynomial with two terms in our denominator, we have to use long division. This is the exception here. Because I have a 5x plus 4 up here and a 5x plus 4 up here, I'm going to treat the 5x plus 4 as a monomial, even though it is a binomial. And so when I go through do my division, I'm going to divide each of these terms up here by 5x plus 4. And so what I'll get is something that looks like this. I'm still going to have my GCF on the outside. Notice that I never get rid of that GCF on the outside. But when I simplify on the inside, I've got to divide both of these, this whole term by 5x plus 4 and this entire term by 5x plus 4. All right? And so I'm going to have an 8x times 5x plus 4 divided by 5x plus 4 minus a 3 times 5x plus 4 divided by 5x plus 4. And now with that, you can see that the 5x plus 4 is canceled there. The 5x plus 4 is canceled there. And now you're going to have your 5x plus 4 on the outside. And on the inside, you'll be left with 8x minus 3. All right? And that will be your solution to this polynomial here in factored form when factoring out the GCF. And that my goal for when we're doing this factoring out the GCF is for you to be able to start here and without going through all of these steps here, get to here. All right. Of course, as we're starting out learning, that's going to be a difficult task to do. But as you get better and better at factoring out the GCF, it'll become easier and easier for you to do so that you won't have to go through this entire step here. And this entire step here is going to be kind of instinctive. That is the goal. Of course, I don't expect you to be able to do that right now. The last thing that I want to talk about in this video is factoring by grouping. All right. Now, there's one important thing that we should always know about factoring by grouping. It only works, this method only works for polynomials with 4 terms. Either the polynomial is going to have 4 terms, or we're going to turn the polynomial into a polynomial with 4 terms. And that's later in our study of factoring. The first thing we want to do here is to factor the GCF out of all of the terms if possible. That means all 4 terms. All right, this is not going to be a step that's going to work for every single problem, but for some problems we will do this step here. Then we're going to group the polynomial 2 by 2. Right, since there's 4 terms, I'm going to group the first 2 terms together, and I'm going to find and factor out the GCF. And I'm going to group the second 2 terms together, and I'm going to find and factor the GCF of those second 2 terms. All right. Once I do that, I am going to be in a case of a problem that looks almost exactly like this example right here. All right, and then we're going to finish the rest of the problem going through this process here. Again, my goal is for you to see this and immediately be able to write this. But this is the mathematical thinking that we actually go through here. All right, let's look at a couple of examples. All right, in this first example, we have x cubed minus 6x squared plus 5x minus 30. Notice here I have four terms. This is my first term, this is my second term, this is my third term, and this is my fourth term. All right, looking at each of those terms, there is not a greatest common factor that includes a common factor for all four terms. For instance, this is a 1 in front of this x cubed, right? And so my GCF can only be a 1, and we don't normally look out for 1, right? We look for numbers that are bigger than 1. In addition, this one has an x, that one has an x, that one has an x, but that one does not have an x. So that means there's no GCF out of all four of those terms. And so what I'm going to do is I'm going to jump right into grouping these 2 by 2. Group the first two together, and I'm going to group the second two together. Now my goal is to look at the first two terms and see what the GCF is, right? And so if I look at x cubed and 6x squared, my greatest common factor is not going to include a number because there's a 6 there and there's a 1 there. Again, we don't look for numbers 1 as the number. We want to look for a number that's bigger than 1. And here, both of these have an x in it, and the smallest power, or the smallest exponent, is x squared. And so I'm going to get x squared as my GCF. I multiply it on the outside, and I divide it on the inside. And this is when I want those steps to get sort of smaller, right? If I take the x squared and divide it into x cubed, 3 minus 2 is 1, so we're going to get x to the first power. And if I divide this term by x squared, the x squareds are going to cancel, and we'll be left with a minus 6. Okay, notice how I wrote that in factored form with the parentheses and everything. That is perfectly fine. Now I'm going to look at the second two terms, and my GCF here is going to be a 5. All right, and since I grouped this 5x is now acting as a leading term when I'm factoring, and since it's positive, I'm going to make sure that that 5 is positive. So I'm going to say a plus 5. Write it on the outside as a multiplication, and the thing that goes into parentheses is when I divide both of those terms by 5. 5x divided by 5 is x. Negative 30 divided by 5 is minus 6. Now when we look at this example here, both of these terms now have an x minus 6 in them. All right, kind of like that last example that we just looked at. And so what we're going to do here is we're going to write our factor out that x minus 6. And from this first term, if I divide by the x minus 6 on both of these parts of this term here, the x minus 6 is going to cancel. And so the only thing I'm going to be left with is the x squared. And the same thing is going to happen here. I have a 5 times an x minus 6. If I divide by x minus 6, I'm only going to be left with that 5 there. So that's going to be a plus 5. Now I've written this polynomial here with 4 terms as a product of 2 polynomials. That tells me that I'm done with this example. Let's look at another example. Part B. I have x cubed minus 9x squared plus x minus 9. Notice that there is not a GCF in that entire polynomial there. And so what I'm going to do is I'm going to group these first 2 terms together, and I'm going to group the second 2 terms together. Out of the first 2 terms, I can factor out an x squared, which is going to leave me with an x minus 9. And out of the second 2 terms, I can't factor out anything. My GCF is 1, right? And so I can write this as just an x minus 9. Now, if you really, really wanted to, you could write this 1 here. That is the GCF between them. But again, we don't normally look for GCFs that are larger than 1. But for a lot of people, writing this 1 here helps them when they get to the next step. All right? Because remember, if I look at this example here, both of these terms have an x minus 9 in them. And so our goal should be to factor out that x minus 9 next, since that's our new GCF. And out of this first term, notice the x minus 9s are going to cancel, and I'm going to be left with just x squared here. And the second term, When the x minus 9's cancel, I'm just going to be left with 1. You don't want to write a 0 there, you want a 1. And so that's why some people still like to write that 1 there, even though it's not a necessary thing to do. But I'm going to get a plus 1. And now we can see that our polynomial has gone from a sum, just a regular old polynomial in its standard form, to a multiplication or a product of 2 or more polynomials. That means we're done, and that's my solution. Again, you can check your solution to these by multiplying it all out. I'll save that for you in your own time. But this concludes our video on the introduction to factoring, the greatest common factoring, and factoring by grouping.